Okay, Common Core Algebra 2. So today we're going to look at 5.7 Part 2, which is all about writing polynomials. Okay, now it's basically the opposite of what we've been doing. Before, you were given a polynomial and we found the zeros, and then those kind of helped us with the factors. We did like synthetic division, we looked at our graphs a little bit. Today I'm going to give you the zeros, we're going to write the factors, and then use those factors to write our polynomials. Okay, so it's the opposite of Part 1. A couple things we need to keep in mind is our factor theorem. So zeros to factors. If c is a zero, remember, of some polynomial, then that means that x minus c has to be a factor of that polynomial. And in fact, you can help factor by doing synthetic division on that, and that'll help us factor out to the other polynomial, and so on and so on. So an example there, if 8 is a 0, then that means x minus 8 must be a factor. Okay, so I may tell you that 8 is a 0 of some polynomial. That means x minus 8 must be one of the factors of the polynomial. Okay, the other thing to keep in mind is we talked about conjugate pairs. So both complex and irrational numbers, or complex and irrational zeros, when we're talking about this case, they're always going to come in conjugate pairs. Meaning, if I have 2 minus 3i, then 2 plus 3i is also its conjugate pair, and so therefore if one is a 0, they both have to be zeros. You can do this with irrational numbers too. If I said 6 plus the square root of 17, then 6 minus the square root of 17. Those are conjugate pairs. And if one is a 0, then they both have to be zeros. Okay, so zeros for complex and irrational numbers come in conjugate pairs. Okay, an example of what writing a polynomial would look like. Suppose I tell you that you need to write some polynomial. Okay, so there's a lot of different options. I'm just telling you to write one possible polynomial that has 3 zeros, -3, 4, and 2, and the leading coefficient can be 1. Okay, so if I change the leading coefficient, we can make a lot of different polynomials. We're just going to say the leading coefficient is 1. Okay, so 5 zeros, -3, 4, and 2. Well, we're looking for some polynomial, meaning we're trying to find some x, f of x. Okay, we're naming the polynomial f. We're saying x is our variable. That's what this tells us here. And since -3 is a 0, then x minus a -3 is a factor. Since 4 is a 0, x minus 4 is a factor. Since 2 is a 0, x minus 2 is a factor. Now I would just rewrite this, because who wants to have minus a negative? We can make that a plus. So really it's like f of x equals 1, x plus 3 times x minus 4 times x minus 2. Okay, and if I didn't tell you to multiply out those polynomials, that would be all you need to do. This is f of x in its factored form. And remember, zeros are also called x-intercepts. So we would actually have here, you could even add, x-intercepts at -3, 4, and 2. Okay, and because we have 3 zeros here, this would end up being an x to the third polynomial. We could have multiple terms for that though. Okay, another example, just to kind of throw a little loop into this. So same idea, we're going to write a possible polynomial if we have zeros 1 and 2i. And again, the leading coefficient can be 1. We'll keep it simple like that. So here it looks like I have 2 different zeros, right? Okay, but the problem is this is an imaginary number, so we need to keep in mind our conjugate pairs. So if I say you're given zeros 1, 2i, that means it also has to have a third zero of -2i, because these two are conjugate pairs. Okay, 2i and -2i, so they both have to be zeros. Now here is where these can get a little complicated, because when we talk about these polynomials, we don't want to have 2i and -2i in our polynomial. We're going to start off by, again, creating some f of x, and we could use g of x or h of x or t of x, whatever we want. We're going to use f of x typically. And so I'm going to write it. I've got x minus 1 because 1 is a 0, x minus 2i because 2i is a 0, and x minus a -2i because -2i is a 0. So same idea there that we did before. And again, I'm going to change that negative to a plus 2i. Okay, now here the problem is we don't want these 2i's in there. Okay, so I want to FOIL those, or multiply those two binomials out. And what's going to happen, because our conjugate pairs exist, it's always going to end up eliminating your i's. If I multiply those two, I would get x squared plus 4. Okay, and if you're not sure, go ahead and multiply those. And remember, that means x times x times 2i, and then -2i times x, and -2 times 2i. And it should simplify out to x squared plus 4. If it didn't, we made a mistake, and we can talk about that again in class tomorrow. So if I told you to write in factored form, this would be your most factored form. Suppose I told you to take it one more step and write it in standard form. Well, then again, we'd need to do the same thing basically that we did right here. X times both of these, and then -1 times both of those. And then since I told you to put it in standard form, remember we need to order them appropriately. If we did that, we'd end up with 1x cubed minus x squared plus 4x minus 4. Now I just brought the 1 down again because remember that leading coefficient is supposed to be 1. That's a bit redundant. We don't have to put that in. But just so you're aware, that is the leading coefficient that you were told to use. Okay, so big thing is that your zeros become your factors. Okay, and imaginary numbers exist in conjugate pairs. Okay, so if we know one imaginary zero, we actually know two. Okay, the other big thing is that remember, zeros are also called your x-intercepts, and that's going to be important when we go back to graphing these again. All right, that is it, guys. We'll see you next time.